Today we're going to begin Chapter 1 with Chapter 1, Lesson 1, Rational Numbers. Let's go to page 59 in our notebook. And our new essential question is, why is it helpful to write numbers in different ways? So for these notes, I have foldable notes that look like this. And if you are not in the classroom and you are at home, you can still draw this out and even shade in lightly with colored pencil if you choose. So this is my version here of a Venn diagram. Remember that in a Venn diagram, where they overlap is what they have in common. So this whole entire thing is on the yellow paper. It's all overlapping on the yellow paper, so everything here is a real number. Real numbers are all numbers that are points on a number line. So when we have real numbers, we can break them down into two categories. They're either rational or irrational. Let's discuss irrational numbers. Irrational numbers cannot be written as a fraction. So for example, pi or the square root of 2. Irrational numbers are non-terminating, which means that they go on and on forever without a pattern. So it's important to know that this is without a pattern. Like pi, it goes on forever and there's no pattern to the numbers. Rational numbers can be written as a fraction, and it does include repeating and terminating decimals. So the decimals will either end or stop like this, or they will repeat like this number here or this number here, because this is technically 0.6 repeating. So although these are non-terminating, they are repeating, which means that they have a pattern, versus irrational, which does not have a pattern. So getting even more specific, integers. Remember, integers are overlapping, so integers are rational numbers and they are real. Integers are whole numbers and their opposites. Please don't forget that a whole number includes 0, even though it does not have an opposite. So then let's get even more specific. Whole numbers are natural numbers and 0. So what is a natural number? They're counting numbers. When you count, you begin with the number 1. So we would have 1, 2, 3, and so on. Let's look at page 58 in your notes. And I'd like for you to complete these on your own. So hit the pause button and change these values. If you haven't already done so, please hit pause. And let's look. How do we change 3/4 to a decimal? Well, remember, the fraction bar means to divide. So if we go step by step, 3/4 really means 3 divided by 4, or the long way like this, 3 divided by 4. We know that 3/4 is 0.75. What if we have a mixed number that is an integer and a fraction? If we want to change this to a decimal, one way that you can think about it is the 2 is still going to be there as our integer, so it's 2 point something. And what is the something? 3 divided by 4, or whatever fraction is here. And then number 3, change negative 0.4 to a fraction. So first of all, we know that it's negative. Second, what position is this number in? It's in the 10ths place. If we know it's in the 10ths place, we can say negative 0.4 is negative 4/10, and that's technically the proper way to read it and say it. but we would have to simplify, always simplify. So for directions, you're going to write the number over the place value. It's in the 10th place. Put it over 10, and then just simplify, reduce. Now let's talk about changing a repeating decimal to a fraction. Essentially, what you're going to do is subtract 1 from the denominator place value. So we know 0.5. 0.5 is 5 over 10, because it's 5/10. But what if we wanted to know 0.5 repeating? If we want to know how to change 0.5 repeating to a fraction, start with 5 over 10, because it's 5/10, and then subtract 1 from the place value, and that would give us 9, because 10 minus 1 is 9. 5/9 is 0.5 repeating, and you can even check it if you'd like on the calculator, 5 divided by 9. Okay, what about 0.27? 0.27 is 27 hundredths. That's the proper way to say it because it's tenths, hundredths. And yes, you would always simplify if possible. But what if we have 0.27 repeating? Know that 0.27 is 27 hundredths, and then just subtract 1 from the denominator, which is the place value. So subtracting 1, 100 minus 1 is 99. We would get 27 over 99. And as I said, if possible, always simplify. There's a common factor of 9. 9 can go into 27 3 times and 99 11 times. So we would say 0.27 is 3/11.